Before we begin Unit 28, here is the answer to the Unit 27 question. The best answer is choice D.
The major problem associated with non-hazardous solid waste is the sheer volume. Integrated Waste Management, or IWM, follows a three-priority approach. The first priority is to prevent the primary or original pollutants from being produced. The second priority involves reusing, recycling, and repairing existing products in order to minimize secondary waste. The third priority is to manage or dispose of those primary and secondary wastes that could not be eliminated. Integrated waste management applies to hazardous materials as well. However, there are some important distinctions, as these substances pose an immediate threat to human health and the environment. Most of the hazardous waste disposal methods are very expensive, and although quite safe if monitored and maintained properly, there can never be a guarantee of zero future risk. Unit 28. Did you hear that?
Noise affects more Americans than any other form of pollution, so it's ironic that it seems to get the least amount of attention.
Although we rarely give it much thought, we are constantly exposed to sound, and its effects can have more of an impact on our lives than we realize.
In order to distinguish between sound and noise, consider the age-old question: if a tree falls in the woods and no one hears it, is there a sound?
Technically, the answer is yes. Sound is a series of compressions of air molecules that travel through the air, and it doesn't matter whether it's heard or not.
Sound only becomes a noise when it's considered unwanted or annoying.
Therefore, if someone asks, if a tree falls in the woods and no one hears it, is there a noise? The answer will be no.
To summarize, a noise needs to be heard and considered unwanted. A sound does not.
When air is disturbed, a series of molecular compressions moves through the medium in a manner similar to that of a falling line of dominoes.
Eventually, these sound waves strike the eardrum, causing tiny bones in the middle ear to vibrate.
These vibrations send hydraulic pulses through our inner ear, stimulating the nerve cells of the cochlea. Electrochemical signals are then transmitted to our brains and interpreted as sound.
Depending on what nerve cells are stimulated, we hear different things.
The two fundamental properties of sound are amplitude and frequency.
Amplitude, or loudness, is measured in a unit of pressure known as the decibel, abbreviated small d, capital B.
Decibels range on a scale from 0 decibels, no sound, to 140 decibels, jet takeoff.
A few more helpful reference estimates for loudness are the threshold of hearing, 20 decibels, a quiet library, 50 decibels, normal speech, 75 decibels, and a lawnmower at 5 feet, 90 decibels.
Frequency, or pitch, is measured in cycles of waves per second, or hertz, abbreviated capital H, small z.
The human ear can hear between 20 to 20,000 hertz.
The higher the frequency, the more waves per second, and the higher the pitch.
For example, a foghorn, 250 hertz, is a lower frequency and produces fewer waves per second than a teapot whistle at 1,000 hertz.
Men usually have a lower frequency or pitched voice than women. It all depends on the length of the vocal cords.
Keep in mind that sound is caused by pressure. Short-term exposure to very loud noises can cause damage to either a person's eardrum, the small bones of the middle ear, or to the receptor nerve cells of the inner ear.
In all cases, hearing will be impaired. However, as long as the damage is not severe, the effects are usually not permanent.
Unfortunately, repeated exposure to loud sounds over an extended period of time can lead to permanent hearing loss.
Based on existing hearing loss data, the Occupational Safety and Health Administration has set the workplace limit for noise exposure to a time-weighted average of 90 decibels for an 8-hour workday.
By law, employees must wear hearing protection on the job if noise levels exceed these limits. However, there are no laws governing how loud people may listen to their music or mandates forcing them to wear hearing protection when they mow their lawns or freely choose to expose themselves to dangerously loud sounds.
There are two types of noise-induced hearing loss, conductive and sensory neural.
Conductive hearing loss occurs when there is damage to the outer or middle ear, but the inner ear nerve cells are functioning normally.
Conductive hearing loss gets its name from the fact that sound is not transmitted or conducted to a normal inner ear.
These types of losses often correct themselves and can usually be medically treated.
Hearing aids amplify sounds. As long as the acoustical energy is successfully transmitted to a healthy inner ear, a person will be able to process the signals and interpret the sound.
For this reason, if the conductive hearing loss is permanent, a hearing aid is usually all that is needed to restore hearing to acceptable levels.
The second type of noise-induced hearing loss is referred to as sensory neural loss.
The outer and middle ears of a person suffering from sensory neural hearing loss are able to conduct sound to the inner ear. However, the damage caused to the nerve cells that detect acoustical energy prevent corresponding electrochemical signals from being sent to the brain.
People suffering from sensory neural hearing loss are unable to distinguish certain frequencies, and they therefore hear garbled or distorted sound.
Although breakthroughs in technology are improving their effectiveness, hearing aids are not as helpful for sensory neural hearing loss as they are for conductive loss.
In many instances, all the hearing aid is doing is amplifying a distorted sound.
Even if the amplitude or duration of a sound is not enough to cause physical damage to the ear, unwanted sound at any decibel level or time interval can affect a person's psychological well-being.
Almost everyone can recall a time in which noise has created an uncomfortable situation.
Noise is a variable that must be processed by the brain so that a person may function on the tasks at hand.
Most of the time, people are unaware that the brain is processing the noise for them. Sometimes, however, people are very aware of the noise. Either way, exposure to noise creates stress.
Although the noise may begin as or remain a psychological distraction, many times continued exposure to such unwanted sounds results in stress-related physical ailments such as hypertension, gastrointestinal issues, and heart disease.
Many municipalities have set allowable limits for background noise that are designed to protect sleep at night and conversation during the day.
The issues involved in the majority of residential noise complaints are not about the loudness, but rather the quality of the noise.
For example, intermittent low-level sound is usually reported to be more annoying than a steady, louder sound.
For this and other similar reasons, regulating ambient sound and enforcing noise ordinances is very difficult.
Fortunately, noise is the one pollutant that we can completely control.
We have the technology to solve almost any noise pollution problem. The question is whether or not we are willing to spend the effort, time, and money to address it.
Remember that noise is any unwanted sound, and people do not always agree when it comes to what is and is not noise pollution.
If you live directly on an interstate highway, you will almost certainly feel that the high costs associated with constructing noise barriers between you and the traffic are worth every penny.
Someone who lives 5 miles away might see that as a huge waste of money.
Although noise is probably our most universal pollutant, it also affects individuals in different ways.
Comparing its severity to some of the other environmental issues we are facing as a global community, noise will most likely continue to be an issue that is best handled at the state, local, and personal levels.
Try telling that to the guy who hasn't slept in weeks because he can't stop his faucet from dripping. Here's your question for Unit 28.
Which of the following statements is false?
Choice A. The two fundamental properties of sound are amplitude and frequency.
Choice B. Noise is basically any unwanted sound.
Choice C. Noise affects more Americans than any other form of pollution, so it's understandable that it receives the greatest amount of attention.
Or Choice D. Noise can cause damage to either a person's eardrum, the small bones of the middle ear, or to the receptor nerve cells of the inner ear.
The answer and explanation are provided at the beginning of Unit 29.